Students, welcome to the first video lecture of chapter number 2. From today, we are going to start chapter number 2, relations and functions. The first topic of this chapter is, students, Cartesian product of sets. Let us start with the definition of Cartesian product of sets. Say A and B are any two non-empty sets. Let us say that set A is equal to 1, 2, 3 and set B is equal to, say, A comma B. Then Cartesian product A cross B is defined as the first element I take of set A and second element I take of set B and I make a pair 1A. Then students 2A. Then students 3. So take all three elements with first element of B. Then I write 1B, 2B, and then students I write. So this gives us, students, Cartesian product of sets A and B. In the Cartesian product A cross B, the first element in the ordered pair belongs to first set and second element in the ordered pair belongs to second set. So if I generalize, then students I can write A cross B is equal to set of ordered pairs xy such that x belongs to A and y belongs to B. So A cross B is set of ordered pairs where in the ordered pairs the first element is of set A, students, and the second element is of set B. So this is what is, students, the definition of Cartesian product. Now see, cardinal number of A is 3, cardinal number of B is 2. Therefore, cardinal number of A cross B will be n of A into n of B, and that will be 3 into 2, 6. Students, if number of elements of set A are 3, number of elements of set B are 2, then number of elements of set A cross B will be 3 into 2. How many? 6. This is, students, what we have to remember in the definition of Cartesian product. So let us define formally again what is Cartesian product. For any two non-empty sets A and B, A cross B is set of ordered pairs xy such that x is an element of A and y is an element of B. In the ordered pair xy, the first element x will belong to the first set in the Cartesian product and the second element y will belong to the second set in the Cartesian product. So this is what, students, we have to study regarding Cartesian product. Then, students, in general, we have some results based on Cartesian product. First, that Cartesian product A cross B will be set of ordered pairs xy such that x belongs to A and y belongs to B. Then, students, in general, A cross B not equal to B cross A. Here, if I ordered B cross A, this ordered pairs will change to A1, A2, A3, B1, B2, and B3. You can definitely check that A cross B not equal to B cross A. Third, if A cross B is equal to B cross A, this implies, students, that set A and B are equal. So this is the third definition of equal sets. Two definitions, students, already we have studied in chapter 1, that if A subset B and B subset A, then A is equal to B. Then if two non-empty sets A and B have same number of elements and same corresponding elements, then A and B are equal sets. And the third definition, if A cross B is equal to B cross A, students, then definitely we have A is equal to B. Now if either A or B, if A is equal to null set or B is equal to null set, then definitely Cartesian product A cross B will be a set. Then, if either of the two set is an infinite set, say if A is infinite set or B or both, then A cross B will be also an infinite set. So, if at least one of the two sets A and B, one set is infinite, then A cross B will be also infinite. These are the general results based on Cartesian product. Now students, let us do few basic sums of exercise 2.1. Students, let us do few basic sums of exercise 2.1. Now, yes students, our first question reads as follows: if x by 3 plus 1 comma y minus 2 by 3 is equal to 5 by 3 comma 1 by 3, find the values of x and y. Okay, exercise 2.1, question 1. So we are given ordered pairs x by 3 plus 1 comma y minus 2 by 3 is equal to 5 by 3 comma 1 by 3. Then find the values of x and y. Okay, second question I'm writing. If set A has 3 elements, cardinal number of A is 3, and set B has 3, 4 and 5, then find the number of elements of A cross. Okay, let us note on the first 3 questions. Then set G is equal to set of elements 7, 8, and set H is equal to set of elements 5, 4 and 2. Then students find G cross H. Okay, and the other information is find H cross G. Okay, let us write one more. Now in fourth question, state whether the following statements are true or false. If the statement is false, then rewrite the given statement. Okay, so in that first statement, P is given as M and set Q is given as N. Then P cross Q. Okay, let us do the question, then we verify. Okay students, now all of you please concentrate. Our first sum, if two ordered pairs are equal to, then their corresponding elements are also equal. Therefore, x by 3 plus 1 is equal to 5 by 3 and y minus 2 by 3 is equal to 1 by 3. Taking 3 as LCM, x plus 3 by 3 is equal to 5 by 3, and here I can write y is equal to 2 by 3 plus 1 by 3, which is 3 by 3, 1, and here cancelling 3 and 3 we get x is equal to 2, y is equal to 1. This is our answer. Very simple students, this is very simple. Now students, our next question. Cardinal number of A is 3 and set B has 3 elements which are 3, 4, 5. The number of elements of set B I can write as 3. And number of elements in A cross B will be number of elements of A into number of elements of B. So 3 into 3. So cardinal number of A cross B will be how much? Number of elements students in A cross B will be 9. Now students, let us operate G cross H. G cross H is set of ordered pairs 7, 5, 8, 5, then 7, 4, then 8 4. Then 7 2 and 8 2. So these are the ordered pairs which we have written. So how many ordered pairs? 6. You can check. Cardinal number of G is 2. Cardinal number of H is 3. Therefore, cardinal number of G cross H will be 2 into 3, 6. Same way here. H cross G. So 5 7 5 8. 5 7 5 8. Then 4 7 4 8. Then 2 7. Then 2 8. Okay. Cardinal number of H cross G, you can check it is 3 into 6. Definitely we can say that G cross H not equal to H cross G. If A cross B is equal to B cross A, then and only then students set A and B are equal sets. Now students, question 4. State whether the following statements are true or false, and if false, then rewrite the statement correctly. Okay, now if I operate P cross Q, this will have 4 ordered pairs. Mn, Mn, then Nn, and the fourth pair will be Nn. So as per the given, statement is false. The given statement is false because in the question they have given P cross Q is equal to Mn and N. Only 2 ordered pairs are given. Actually, students, we have 4 ordered pairs. Now this is easily understood. So you can rewrite the statement for given sets P and Q. P cross Q is equal to this is the correct statement. This is very easy, students. Second statement, it reads as follows, students. Second statement, if A and B are non-empty sets, then A cross B is a non-empty set of ordered pairs xy such that x belongs to B and y belongs to A. This is false, students. In the ordered pair, now all of you know, in the Cartesian product A cross B such that it is set of ordered pairs xy, x belongs to A and y belongs to B. In the ordered pair, first element belongs to the first set in the product and second element belongs to the second set in the product. So as per the given statement is false. This is very simple, students. Very easily we can write. So the given statement is false. And the correct statement I have already written, students, on the board. Now students, the third statement. Question 4, students, third statement, that if A is equal to 1 2 and B is equal to 3. Okay, let us note down. Question 4, statement third, set A is equal to set of elements 1 2 and set B is equal to set of elements 3 4. Then A cross B intersection null set is equal to null set, students. Is this statement true or false? Now students, B intersection null set is null set and A cross null set is null set. Therefore, the given statement is true. Just now we took the results that in the Cartesian product, if either of the two sets or both are null set, then students, definitely the Cartesian product will be null set. So third statement is true. Okay, students. Question number 5. Set A is equal to set of elements minus 1 1. Okay. Question number 5. Set A is set of elements minus 1 comma 1. Operate A cross A cross A. Okay. First we find A cross A. Now students, in A cross A, we have set of elements minus 1 comma minus 1 into minus 1 comma minus 1. So if I operate A cross A, I will get set of ordered as minus 1 minus 1 minus 1 1 minus 1 and 1 1. So students, in A cross A, number of elements will be 4. Now if I want to operate A cross A cross A cross A, then this is minus 1 comma 1 into minus 1 minus 1 minus 1 1 1 minus 1 and 1 comma 1. Now take minus 1 and multiply with all 4 pairs. So this becomes triplets. Minus 1 minus 1 minus 1 minus 1 1 minus 1 1 minus 1, then minus 1 1 1, then 1 minus 1 minus 1, again multiply 1 with all 4 ordered pairs. 1 minus 1 1, then 1 1 minus 1, and the last triplet will be 1 1 1. So in general, students, in general, A cross A will be such triplets x, y, z such that x belongs to A, y belongs to A, and z belongs to A. And if there are 3 different sets A, B, C, then A cross B cross A is equal to triplet x, y, z, where x belongs to A, y belongs to B, and z belongs to C. So a triple product A cross A will be set of triplets x, y, z, where x belongs to the first set, y belongs to the second set, and z belongs to the third set in the Cartesian. Okay, now students, question 6 and 7. Now we go for questions 6 and 7. Okay, in the sixth sum we are given A cross B, students. Okay, question 6. A cross B is equal to set of ordered as AX, AY, then BX and BY. Then we have to find sets A and B. Okay, students, we have to find sets A and set B. The first element in the ordered pair will belong to A. So A belongs to capital A and B belongs to capital A. Therefore, set of elements A, B is set A. And X belongs to B and Y belongs to B. Therefore, set B will be set of elements X and Y. It is very simple, students. Very easily you can do question number 6. Now students, question number 7. We are given set A, B and C. Okay. Question 7. Set A is set of elements 1, 2. Okay. Set B is set of elements 1, 2, 3, 4. Set C is set of elements 5, 6. Set D is set of elements 5, 6, 7, 8. Verify the following result. The first result is A cross B intersection C is equal to A cross B intersection A cross C. Okay, students, we have to verify this result. Now in verification, what we have to do, we have to operate LHS separately, we have to operate RHS separately and check their answers are same. So let us start with LHS. It is A cross B intersection C. What is set A? 1, 2. What is B intersection C? Nothing is common students between B and C, so it is null set. So this will be null set. In Cartesian product, when one of the two sets is null set, the Cartesian product is null set. Now, RHS A cross B intersection A cross C. Let us operate A cross B. It is 1, 1. 1, 2, 1, 3, 1, 4, then 2, 1, then 2, 2, then 2, 3, then 2, 4. Its intersection with A cross C, 1, 5, 1, 6, 1, 7, 1, 8, 2, 5, 2, 6, 2, 7, and 2, 8. Definitely check again this intersection is null set. Therefore, LHS is equal to RHS. Hence, verify. Students, we have verified the result. So this type of questions are very easy students. Once you know the sets, you can very easily operate it, students. Now, question number 2 of means part 2 of question number 7, students. Now, A cross C is a subset of B cross C. Okay. Let us operate A cross C. A cross C will be 1, 5, 1, 6, 2, 5, and 2, 6. And B cross B is 1, 5, 1, 6, 1, 7, 1, 8, 2, 5, 2, 6, 2, 7, and 2, 8, 3, 5, 3, 6, 3, 7, and 3, 4, 5, 4, 6, 4, 7, and 4, 8. 16 elements. 1, 5, 1, 6, 2, 5, and 2, 6. So definitely we can say that A cross B is subset of B cross B. Hence, verify. So students, we will verify the result. Now for the time being, students, I am not doing question 8, I am doing question 9. Let A and B be any two sets such that n of A is 3 and n of B is 2. Okay, students. Question 9. N of A is 3 and n of B is 2. And ordered pairs x1, y2, and z1 belongs to A cross. Which are the three ordered pairs? x1, y2, and z1 belongs to A cross B. Now first element belongs to A. So x, y, z belongs to A. So set A is the set of elements x, y, z, and 1, 2 belongs to B. So set B will be set of elements 1, 2. This is very simple, students. It is based on the definition of Cartesian product. We have told students in the ordered pair, the first element belongs to the first set in the product, and the second element belongs to the second set in the product. Okay, students. Now, tensor. The Cartesian product AA has 9 elements. Question 10. N of A cross A is equal to 9. Therefore, N of A will be 3. This is very simple. Because this is equal to N of A into N of A. So, cardinal number of set A is 3. Then minus 1, 0 and 0, 1 belongs to the set A cross A. Minus 1, 0 and 0, 1 belongs to A cross A. So in that minus 1 belongs to A, 0 belongs to A and 1 belongs to A. Therefore set A will be set of elements minus 1, 0 and 1. So we are going to write the remaining elements of A cross A. The remaining elements of A cross A. Now A cross A minus 1, minus 1. Then minus 1, 0 already written. Minus 1, 1. Then 0, comma, minus 1. Then 0, comma, 0. 0, 1 written. 1, comma, minus 1. 1, comma, 0. 1, comma. This are the remaining 7 elements. Remaining elements of A cross A means 7 elements. So this is how students we operate A cross A. So intentionally one sum students, sum number 8 I have kept pending. That question students will be covering in the next lecture. Do this sums twice, once in Faraday and once in rough. Students, here we conclude the lecture. Thank you. 8 sum will do next time.